Okay, welcome everyone. This tutorial will be about solving an example about the graphical position analysis. All right, and we will solve together this problem. I have chosen to record a video for solving such a problems because there are things that cannot be explained online or by Zoom or these softwares. All right, so this is a typical 4-bar linkage problem where we can use the graphical position analysis. All right, so what you need guys is to have your you have your engineering equipment with you. Okay, so please make sure you have a protractor and a compass, okay, and a ruler. All right, okay, but instead of a ruler I will use today this scale here, which is similar to a ruler. All right, let's start solving the problem. So let's read it together firstly. Okay, so this is a 4-bar linkage problem. Now, A, using graphical position analysis, determine the appropriate angles of all links if link 2, this is link 2, rotates clockwise, so it will be rotating clockwise by an angle of 15 degrees, which means that theta 2 is equal to 75. All right, and now we will define our angles. But theta 2 is always the angle, okay, the angle which corresponds to link 2. So now we have, this is 90 degrees angle, so this will be our theta 2. All right, so now it says indicates the angle clearly, and there is part B and part C. We will read it after we are done with part A. All right. So now the first thing I need to do is to put the givens. So I have a given that theta 2 is moving, as you can see here, by 15 degrees. All right, so using the graphical position analysis, I need to determine the appropriate angles of all links. All right, so I need to redraw the drawing based on the fact that link 2 is rotating clockwise by 15 degrees. So how to start this and how to use our protractor and compass. Okay, the first step is that I need to measure the length of the parts of all the parts or all links. Okay, so if I can come here from 0, okay, let's number it, but it's already numbered in the question. So I have link 1, 2, 3, and 4. All right, so link 1 here, you can write it here. Okay, link 1, which is equivalent to AB. All right, sorry, link 1, this one, which is equivalent to AO. All right, so this will be AO. Link 2 here is AB. All right, AB. link 3 is equivalent to what? To BC. And link 4 is equivalent to CO or OC, all right? So link 4 will be CO. All right, so let's take the measurements. So now for link AB, using the ruler, it's approximately 5 centimeters, all right? So I will write here, it's 5 centimeters. Now for link 2, sorry, please. Let's do that again, all right? So this is link 1. Okay, I need to take the length of link 1. So OA, so it's 6 centimeters, all right? 6 centimeters. Link 2, which is AB, is approximately, this is the 0, 5 centimeters. Link 3, which is BC, is also 5 centimeters. And link 4 finally is 3 centimeters. All right. So after I have identified my lengths, my corresponding lengths for all the bars or the lengths, the first step is that I need to move theta 2, as it says in the question, okay, by 15 degrees. So how to do that? The first step is using the protractor. All right, I will come here. Okay, just flip this. I will come here to the corner. All right, and all right, so this is 5, this is 10, this is 15. I will just put a point here. All right, and now I know that the length of AB, which is link 2, is 5 centimeters. So I will bring just the ruler and I will do just an initial length or initial line, okay, and coming here from 0, I need to calculate it until 5. All right, so this length is just to identify the angle, which I measured using the protractor, and now this is 5, so I will draw a point here. All right, and then I can just I can remove all the extra lines later on. All right, so this is the first step. Now what's the second step? The second step is now if link 2 was rotated, for sure link 3, link 4 will also be different, all right, or will also rotate. So how can I know the locations of link 3 and link 4? The first step is I need the compass, all right? So I have the length of part 3 or link 3, which is 5 centimeters, right? So I will adjust the compass using the ruler, all right, by 5 centimeters. I come here and then adjust it to be 5. Yes. Or another way, I can just use the link itself to adjust my length, okay? And I will come to this point where it's the end of link 2, and I will just draw a circle like that. All right, this is the first step. The second step, I will take the measurement of link 4, which is sorry, it was 3 centimeters. I forgot to write 3. All right, so there are two ways. Either you can just adjust it from here, from the link itself, or from the ruler. All right, so to make sure it's a 3, yes, it's a 3, and I will just now draw another circle or semicircle, okay, like this. All right, I'm done. Next step. All right, the next step. Do you see this intersection point? This will be the point where link 3 and link 4 will intersect after link 2 is moved or rotated 15 degrees C clockwise. All right, so this one here will be 15 degrees. All right, this one here, I know that this one here is 75 degrees because the question says that theta 2 is 75, and I identify theta 2 to be the angle from the positive x-axis to link 2, and that's how we will deal with angles. All right, so just let me finish and use your ruler to match between these points. So I will just match this point, all right, like this, with this point. Again, from this point here, this will be my link, my new link 4. All right, so you can see now I can get an eraser and erase everything extra which I don't need. All right, so this one is also, I don't need it. I don't need this one. Also this one, I don't need this one also. All right, so now you can see that I have my link, my 4-par linkage, the new 4-par linkage using a compass, and this is the graphical position analysis. All right, so you will be given 1 or 2 angles and you will be asked to find the other angles. All right, so what's the next step now? The next step is now I need to determine the appropriate angles of all links. All right, all new links. So this is theta 2, and as I said, I have the positive x-axis. All right, this is the positive x-axis. So this will be my reference for all angles. All right, so what does that mean? This means that I have my theta 2. All right, so this is link 1. All right, so which theta will be here? It will be theta 1. How much is theta 1 with respect to the x-axis, to the positive x-axis? So as you can see, this is theta 1, which is equal to 0. All right, so this is the angle. There is no angle between this link and the positive x-axis. Now coming to here, to this angle here, this will be my theta 3. So how am I going to define theta 3? All right, with respect to the positive x-axis. So it's gonna be something similar to this. So from the positive x-axis, I will rotate to take the link 3, and this will be theta 3. All right, so what about theta 4, which represents the angle of the link 4 with respect to the positive x-axis? It will be this angle. So this is theta 4. All right, I believe now it's very clear, right, how to construct your 4-par linkage after one link is being rotated. Okay, so this system, so I'm solving part A, guys. All right, so this is part A, to indicate all the angles clearly after these givens are being done on the drawing. So this system represents a 4-par linkage. All right, I hope it's clear, guys. All right, so that was the end of section A. Okay, so now let's see what section B says. Section B says use the vector loop method and write the vector loop equation Also draw the vector loop on the drawing, on this drawing. All right. So let's solve the problem as follows. It says that draw the vector loop in the drawing. All right. So what is the vector loop? I believe that you know it from the lecture, and as we will solve the problem, you will know it further. Okay. But for a vector loop, so for example, let's see just as a very simple example. All right. Let's do it here. If I have, let's see, if I have this triangle, all right, that would be my triangle. And for example, this is a 3-part linkage. All right, this is 1, this is 2, this is 3. So I will identify this one as R1, this one as R2, and this one as R3. All right. And for example, I can identify them as vectors. So this one will be a vector in this direction, this one will be a vector in this direction, and that one will be a vector in that direction. Okay. So let's apply this method here. So this is the drawing. Okay. So I will now identify the vectors for this 4-part linkage. So this will be the beginning of my vector, and this will be the end. So this will be R2. All right. And how can I identify the direction of the vector? So I can see that this theta here, all right, you can see that theta is going like that, right, from the positive x-axis. So my vector will be according to that. Now, for example, theta 3 is the angle theta 3 is coming from the positive x-axis all through link 3, right? So link 3 position or direction will be as follows, going from this point to this point. Okay. Now, what about theta 4? Theta 4, the angle of theta 4 is going from the positive x-axis to link 4. So the direction is always with respect to the angle. All right. So the direction will be from here to here. And let me just show these. This is, oh sorry, this is R3. All right. And this is R4. So I have R2, R3, and R4, and I need R1 also because this is a link 1. So link 1 with respect to positive x-axis. All right. This is theta 1. Theta 1 is 0, right? But with respect to the positive x-axis, the link will be from here to here. The vector of this link will be as follows. So this is R1. All right. So now I have solved part of B by identifying the vectors. So let's use the vector loop method and write the vector loop equation for this 4-part linkage. So let me just take this paper. All right. Okay. So let's start. B. Now, let's start doing. We can start from anywhere, all right? But I will start from R2. So, R2 as a vector, it will be plus. So, R2 in that direction, I will just go into the clockwise. Let me write it here. Okay, clockwise direction. Or you can move counterclockwise, but you have to be consistent, all right? So I will start from here and go clockwise. So R1 as I go like this, so it will be positive because it's from the head to the tip, all right? R2 plus R3 as a vector, all right? Why plus? Because as you can see, in for example, I will just give you an example, all right? If I have a vector like that, and a vector like that. So this one v1 and v2. All right, so this one will be v1 plus v2. All right, but for example, another example here, this is from your calculus or physics. All right, so if I have v1 like that and I have v2 like this, my equation will be v1 minus v2. All right, as I'm going clockwise direction. So coming back here, so it will be r2 plus r3. All right, going down here it will be minus r4. Why? Because the direction is reversed. Coming down here it will be minus r1, which all equals to 0. All right, and then using the vector loop methods or equations, I will transform each of these vectors into another form. Now, what is the form? The form says, for example, if I have A as a vector, all right, it can be A e to the power of j theta with respect to A. So this is with respect to A. All right, what does that mean? As follows. Okay, there's something which needs to be mentioned. Okay, that to make it simple for the vector loop method to solve, all right, I need to identify. So I have link 1 is AO, link 2 is AB, right? As you can see here, link 3 is BC, and link 4 is CO. Okay, but let us give them another naming. Okay, so I will say that okay, so I will say that link 1 and link 2, link 3 and link 4. Okay, so I will give link 1 D, link 2 will be B, link 3, okay, will be C, okay, and link 4 will be A. So you are telling me now, why did you choose this naming? Actually, you can label it or name it as you wish. Okay, but let's stick to this name. So link 4 is A. Okay, link 1 is D. This is D. Link 2 is B. This will be my B. Okay, and link 3 is C. But you can name it anything. Okay, now why did I do this naming? Because if I want to transform from this form to this form, I will do the following. Okay, so now R2, which is B, will be P E J theta 2. Okay, we said that A is equal to A e power j theta with respect to A. So here, with respect to R2, I have theta 2, so I will put theta 2. Similarly, R3 is C, so it will be C E J theta 3. All right. Minus R4, which is A E J theta 4 minus D E J theta 1, and all of that is equal to 0. All right, so what do I know from all of these? Okay, so let's see that I know these are the knowns. All right, I'll write them here. Knowns. So I have A, B, C, D. And what are these? These are the length, actually. Okay, so these are here, which are known. Okay, and I know theta 2 and I know theta 1. Theta 1 and theta 2 are known for me. Now, what are the unknowns? Let me just write them here. Okay, unknowns, which I need to find. So unknowns, and the unknowns are theta 3 and theta 4. So I will solve accordingly to find theta 3 and theta 4. Alright, so this is my vector loop equation. That is my vector loop equation, because I did a loop here on the example. There is a loop, alright, and then I have summed all the loop in a specific direction, and then I wrote the final formula. Alright, so this is the vector loop equation. Now coming to part C, let us see. Okay, part C says use Euler identity to separate the equation into real and imaginary parts, and it says that don't solve the problem. You are not required to solve the problem, but you have to set the two equations. Because we have two unknowns, we will have two equations. All right, so let me just use this paper. All right, okay, so all what we need is the vector loop equation. So I will write it again here. Vector loop equation. What is it? So it's PAJ theta 2 plus CEJ theta 3 minus AEJ theta 4 minus DEJ theta 1, which is equal to 0. This is my vector loop equation. So now it's part C. Alright, so what is the Euler identity, guys? So let me just remind you of what is Euler identity. Euler's identity, all right, it says that if I have, for example, A, okay, E, J power theta in general, all right, this will equal to what? This will equal to A cosine theta plus J sine theta. All right, so this is the Euler identity. So let's apply this here. Okay, let's do that, guys. So I have BAJ theta 2. According to this, I will have B, okay, open a bracket, cosine theta 2 plus J sine theta 2. All right, so let me just do it here so I can have more space. All right, so P, okay, open a bracket, cosine theta 2 plus J sine theta 2 plus C, open a bracket, cosine now theta 3 plus J sine theta 3 minus A cosine theta 4 plus J sine theta 4 minus, it can be shown here, yes, minus D cosine theta 1 plus J sine theta 1, which all will be equal to 0. All right, which all will be equal to 0. Now, how to simplify this term? Because we know that theta 1, okay, is equal to 0. Theta 1 is equal to 0. So sine 0 is just 0, and cosine 0 is 1, right? So I can just remove this one by 0 and remove this one by 1, so it will be just D. So I'll rewrite the final formula. All right, let me just rewrite it. So it will be B cosine theta 2 plus J sine theta 2 plus C cosine theta 3 plus J sine theta 3 minus A cosine theta 4 plus J sine theta 4 minus D, which will be equal to 0. Alright guys, I hope it's clear and all of it is appearing. Okay. So now it's all about mathematics, guys. Alright, it's all about mathematics. So let's separate them. Okay, so we will multiply P by cosine and P by sine. So let's do that. So it will be P cosine theta 2 plus J B sine theta 2 plus C cosine theta 3 plus J C sine theta 3 minus A cosine theta 4 minus JA sine theta 4 minus D, which will be equal to 0. Alright, now after that I will just sum the real and the imaginary parts. Okay, so the imaginary parts are all terms which includes J. Alright, so this J refers for the imaginary part. So how can I do that? It's very simple. So let me just open a very big bracket and I will put the real here, real part. So P cosine theta 2. Alright, then plus I will take the C cosine theta 3. Okay, what else? Yes, minus A cosine theta 4, and I will include the D as it's a real part, minus D. Alright, so this is my real part. Now coming to the imaginary part. Okay, and the imaginary part is anything which includes J. Okay, so I will just put plus. I will take J as a common factor between all of these. So J is a common factor. Open up. Okay, so now I have this one. So this one divided by J, it will be B sine theta 2. Alright, here it will be divided by J, it will be plus C sine theta 3. Alright, I will complete here where I have J. Yeah, I have here. Okay, so this term divided by J, it will have minus A sine theta 4, which all will be equal to 0. Alright, so after that I will just separate these two equations. So how to separate them? I will just take the real part as it is, and I will take the imaginary part as it is. Okay, so my equation 1 will be P cosine theta 2 plus C cosine theta 3 minus A cosine theta 4 minus D, which will be equal to 0. Alright, and this is my equation number 1. Okay, this is my equation number 1, and equation number 2 will be the imaginary part. Alright, but since this part here, if I equal this part, just forget about this part. Alright, so forget about this part. If I equal the imaginary part by 0, okay, J will be gone, because I will divide all of that by J. 0 by J is 0. All right, so my second equation will be the imaginary part without dj. So it's gonna be something like p sine theta 2 plus c sine theta 3 minus a sine theta 4, and this will be equal to 0, and that will be my equation number 2. So I have two equations and two unknowns. All right, so now I can solve for theta 3 and theta 4 can be solved. And that was the end of this example. Thank you very much.